Feeling a bit better today. Lab details. Let's add it. Okay, so here is all of the details you need to log on successfully to the lab, and your 4-digit code, same one from yesterday, yeah? So get ready. That's close enough. Good morning, everyone. Yeah, to day 2 of EDU 262. I just had a Zoom meeting at work, so I turned off my virtual background. Yeah, I won't distract you. I'll put back something more official. Yeah, good morning. Um, yeah. So this is our last day. For some of you, it's been since Monday, a very big week. For a few of you, just from yesterday. If you do need help with any lab, yeah, that's what I'm here for. I really want to make this is really a workshop. There's not so much presentation in this class specifically. It's short lessons and then hands-on lab. So if you need help to get going with any of the labs, call me. I've offered enough times. Contact me by chat. So what did we cover yesterday? Yeah, we started off by some chats coming through. Good morning. Yeah. So we started off by going through, this is the analysis and response class to utilize the pro license features. We started talking about alerts versus incidents. How an alert doesn't normally contain much detail. A non-stitched alert, we have an alert severity level, a timestamp, a category, but no details of what actually happened. And an incident is a container object that stores related alerts and information about the assets and artifacts and the timelines and the tactics and techniques that we've identified. So we've learned about the benefit of our causality analysis engine, how if you have the pro license, it can stitch a log with the alert. So for example, our pro agent, every 5 minutes, sends its enhanced endpoint data, the EDR upload that you saw from the agent log. And when the agent sends an alert, it immediately uploads its EED, doesn't wait for the every 5-minute cycle, so that Cortex XDR can look at what happened in the last, during the time the process was running, or processes, when the malware execution happened, when the script ran, what connections were established, what processes started, stopped, which registry changes, which file changes, yeah, all the different activities. So we're able to stitch the alert with the log. That's the causality analysis engine. And we then went through quite detailed causality analysis. I wanted to actually just try something else because I've never seen a stitched alert for this test. We do a test in the EDU 260 class, and we ask to connect. We have a network packet inspection engine, one of the malware protection modules that we have. There we go. Good, that's what I want. Great. Okay. So I tried to connect to URL. I clicked on a link in my email or whatever it was, and then XDR prevented as blocked malicious activity. Application name Firefox, suspicious network connection was detected. Yeah. So actually what we might do is we might look at this as an example of an alert to do a quick analysis of the alert. I've never actually seen this alert as a stitched alert because we only do that testing in the 260 class. Anyone interested? Is there a yes from the crowd? So what do we do? We're going to go and find, well, I've got an easy way of finding my alerts table. I often want to go directly to the alerts table, so I've got a favorite to it. relative URL /alerts. Yeah. And unless you've been busy or other classes around the world, that should be the most recent alert in the last 7 days, the default filter. And sure enough, there it is, and already become part of an incident. So let's do some investigation. And another way we can tell it's been stitched, one way we can tell it's been stitched, is we have the open timeline options. Remember the other method that we use to identify whether it's a stitched alert? It's matched one of my starring rules. It's matched a featured field as well, yeah. But the way we can identify if it's been stitched is if there's a CGO, a causality group owner name. It wasn't the Windows scripting engine this time, it was Firefox. All right, so let's go and do some causality analysis, investigate the causality chain, open the card in a new tab. Let's see what additional detail. Maybe we'll compare it to a non-stitched alert of that type of activity. That's not a bad idea too. So first, before we look at the stitched alert, yeah, if I go and filter my alerts table based on my host name to start off with, so host name contains 6718s, because I did this test this week when we were already running the prevent license, like you did, hopefully, when you did your lab. So let's find malware, pastebin commander control traffic detection. That's the alert name I'd like to also filter on. So I'm going to right click on there and also show rows with that value. Yeah. So if the host contains my endpoint, and you saw I did it once. Yeah. How long ago was that one? When was that alert? Yeah, December 19th. Okay, and the one from today. So if we scroll across again, or don't even need to, we take the one from December 19th, right click, it's non-stitched. I didn't have Pro turned on. So let's look at that before we look at the stitched alert. So this is a brief way of me doing a summary of some of the concepts. So it's that causality analysis engine enabled in Cortex XDR by default. This is the non-stitched alert and our causality graph. Yeah, with a header and the graph itself and the details of the selected node and the additional event details down below. So here's the alert node. It's an XDR agent alert node. And again, we see the severity. There's been a repetition count there as well, but high severity alert, prevented, blocked, the module on my agent that provided the protection, the network packet inspection engine. Yeah, the alert name, pastebin command and control detection, but we don't see any details. If I select Firefox, we're getting information about Firefox. Yeah. It's benign. The SHA-256, but don't know what happened, which IP addresses were involved with that command and control connection. Yeah. So an alert really doesn't have a lot of details. It's the log of the endpoint activity that can be stitched with alerts that can provide the additional visibility. So now let's look at the stitched alert of the same activity. Yeah. All right. Same type of detail on the alert node itself. Yeah. We've straight away identified that Firefox is a causality group owner. Yeah, we could hover over as well with non-stitched, but we see that there is an IP address involved as well. Yeah, Firefox was initiated from a remote terminal session. And if we select Firefox, what type of activities were performed by Firefox? So now we see all the actions. 191, which would be a sum of the 3 system calls, the 112 module activities, plus the 48 file activities, and the 13 network activities. Yes, that would be all together the 191. So we see all the actions listed chronologically, historically, from the newest to the oldest down the bottom. But if we just want to see the network connection details, this is the kind of information we don't have on a non-stitched alert, right? All right, so what's happened here? So the oldest event down the bottom, my source IP, my MAC address, the permissions with which the network connection Network incoming from a loopback. Okay. Network statistics. Okay. Network service. Outgoing connection to this IP. Outgoing connection. That's my IP. That's my IP. From source IP, because we can't see the column at the top. Source IP and source port. So let's stay at the top, yeah? So network outgoings and network any incomings. Yeah, well, that was loopback, so no. Network outgoings from our source IP and port to where? And that's why I have to go to the bottom. I can't scroll across. I can't scroll without going down to the bottom. Yeah, I can't find this slide bar. So source IP and port and destination IPs and ports. All right. And even the destination host has been resolved by reverse lookup. Yeah. Resolving the IP address to the name. So yeah, do we need to do any further investigation? So Mozilla, Amazon Trust, endpoint B. Endpoint B. I didn't even know there was an endpoint B in this lab. Yeah. But as you can see, the ports and protocols and file activities performed by Firefox.exe. Don't know what happened. Yeah. What types of file activities? And again, this is, I probably shouldn't do this. Not a good thing. An instructor normally doesn't, do something they haven't tested before in class as a demo, right? But I thought it was interesting. I missed it. I'm sorry. Yeah. So what types of file activities? File reads, file deletes, file creates, file writes. Okay. JavaScript files, our case.db. Okay. So we're able to see what's happening in terms of processing by the agent because the agent sent the log of all those activity. Doesn't mean they're attack related. Yeah. Not all of them are attack related. This is normal activity for Firefox. Any questions? We also saw, for example, some of the other things we saw. If I could scroll back. Some of the other benefits we have with Pro is sometimes we need to perform remediation, and sometimes we're not sure what needs to be remediated. I don't know if there are any remediation requirements here, so I'm going to select Firefox and see if there are any remediation suggestions based on its process activities. Okay, Firefox started. Yeah, it modified some files, it created a file, it modified a file at data roaming. Yeah, it looks like kind of normal kind of Firefox activity, really. Not sure. They want us to go and delete the file. So some things, again, manual remediation, other things, auto remediation. It thinks that Firefox is still running. It's not, is it? Firefox terminated. Yeah. What about the alert? Let's take it a step back to the alert that we generated yesterday. Yeah. By running the script, one of the scripts. So I won't bother running the script again. We've generated enough alerts that we can use for analysis. We might do a filter again based on my endpoint name. So show rows with that value. And then we'll scroll across and find one of the stitched alerts and the CGO generated by XDR agent. And the CGO is going to be wscript.exe. All right. Good. wscript.exe. Behavioral threat detected. Let's have a look at that one. This is the one we used in the, hopefully you did in the lab. Yeah. So a user ran a malicious VBS script. And we can even identify through the details, the script that was run and where it ran from. Yeah. Analytics profiles because of the analytics engine, the other machine learning engine that you need to turn on after we have at least 30 endpoints for 2 weeks, have enough data to create the baselines for the detectors. Yeah. So here we're seeing an example of when we ran the script, we've identified WScript as the CGO, and it started two different child processes. You can see that graphically. And we can even identify what each of those child processes are. They malware? No, it's benign. But what was the command used for PowerShell? Do we have the ability to deobfuscate and translate it? What happened when you have to escape out of that? What happened when WScript ran? What network connections, file activities, registry activities? Yeah. And so we have here 2 process activities and 8 file activities. So we saw this yesterday. Just going to quickly review, but we saw some files being created that we didn't really want on our endpoint. I didn't remediate though, did I, yesterday? I was doing some demonstrations. So Verilog copy was created, yeah? And we can, of course, see the whole path as well, yeah, in that file path. Now, when we use XQL, this is the kind of things we can query with XQL action underscore type, file underscore name, file underscore path, and look for specific values if you want to, yeah. So yeah, Verilog copy VBS in the app data roaming hidden directory, funny.exe in the home directory, in my home directory. So this might not be a bad example, again, of doing a remediation suggestion, or you could do remediation suggestions for the whole alert across all the different process nodes, or from within an incident. And I worked out the answer. Remember how yesterday, some of the incidents we couldn't get remediation suggestions? Some incidents, they wouldn't show us with a 3-dot on the incident. There are no stitched alerts inside those incidents, so we can't provide remediation suggestions. Only if there are stitched alerts, we can provide suggestions. So I'll keep it brief. Let's just do a suggestion from there from WScript. Okay. All right, created these 2 files. Funny.exe, Verilog copy, VBS. Delete the files. All right, so we'll do that. Select all of the possible remediations, and then we'll remediate. And we could track that, the status of that, by looking at our action center. Remediation of 2 files. Has it completed? Is it partially successful? 1 file completed successfully. So those files are gone. And we'll use those as a continuation of our discussion from this morning for today's material. So that's my warm-up, yeah? Hopefully you're awake now. So yesterday, yeah, we went through causality and analytics concepts, how to perform that kind of causality analysis. We also looked at a section on advanced response we have as part of the Pro license, things like the ability to run Python scripts and remediation suggestions. Yeah. Questions before we move on. Today, what do we cover? I'm not showing the right. So today we move on by going through how to perform queries. Search queries. So we'll talk about the query builder and the query center. We'll then do another module on XDR rules, IOCs, BIOCs, correlation rules. We'll then do a module on asset management, introduction to SQL. So there are really 2 ways for us to go and query the logs available to Cortex XDR. There's the easy way we learn in module 5, a form-based type of query approach where you provide the answers, you provide the values you want, or you have to build the query yourself using SQL. More powerful. So we learned both today. And the last module on external data collection. All right, let's go. Questions? No? Module 5, search queries. Okay. Excuse me. Still got it. Let me pause that. All right, very good. So let's look into module 5. It is quite short, nice lab for it. I'll give it demos as we go through, of course. So how we investigate leads using Cortex XDR tools. So we're going to keep on building up on what we've learned from yesterday and use some of our discoveries through our analysis in continuing this discussion. All right, so we're going to go through building simple queries, how you manage the queries using the query center. Learning objectives for our module is to by the end of it, you should be able to investigate a lead using the tools provided by Cortex XDR. What's a lead? We'll cover that in a second. You'll be able to build a query using our query builder, the easy way of building a query. You'll be able to manage queries in the query center, look at the query results, rerun the query, schedule the query if you want to, if you like it so much, you want to run periodically. And really, there are two types of scheduled queries. There's a periodic scheduled query, which means you want to do it every week, for example, or it's a one-time scheduled query, scheduled one time in the future. Run it on 31st of December. That's it. Yeah. So we call them periodic and non-periodic scheduled queries. If you're going to do your PCDRA, they want you to know the difference between those, yeah? All right, so building simple queries, first of all, what's the idea of a lead? How do we go about using Cortex XDR tools to investigate potential threats? So a lead is our first contact with a potential threat. You might have read an article about some new type of ransomware, or there's a file that's in your part of the world that's traveling with malware or something like that, yeah? So a lead could be from a non-Palo Alto Networks system that's relevant to your environment. It could come from a third party, not Palo Alto Networks. Yeah, they provide, also lots of threat intelligence. It could be well-defined threat information you've read, online articles, the first time you heard about Log4j, whatever it might be. Or it could be users or endpoints that have been reporting their systems aren't functioning properly. I tried to run the application and my screen started shaking a bit and some things looked like it happened, but it's not working, or I got a prevention pop-up. So the user or the endpoint has been reported as acting abnormally. Now, an alert is different from a lead. Yeah, the alerts we've seen, they come into us in the XDR management console. They're readily available to us, and XDR precisely detects and presents the alerts, makes them part of an incident. A lead, the information you have about new malware or malicious IP addresses or other threat intelligence that you want to be able to alert on, it can turn into an alert, but only after you define it in Cortex XDR. So Cortex XDR provides a set of integrated tools to help you locate and to define it. So I'll give you an example. So based on the analysis that we did just before, we found, my non-stitched alert, let's get rid of. We certainly found there was a funny.exe on my server, yeah? So what we may want to do is go and query XDR, well, not query XDR. We may want to ask it to, check the logs. Have there been any other activities on any other endpoints that relate to that same file name? Any file activity, creates, deletes, writes, or something like that, yeah? So at the moment, we have a bit of a lead. There's a file called virus5.exe, yeah, that we may need to investigate a little bit further. So for example, what we could do is we could get out of my remediation suggestions to start off with, and then go into our query builder. So this is an area we haven't really been in before. Under incident response, we have, for further investigation, our query builder, yeah? So let's go and build a query. And there are two ways to build a query. Yeah. I can use XQL, which we learned this afternoon, and that takes us to the XQL editor. That's afterwards. I'll go back to the query builder. There's XQL, or there's the easier form-based queries. What do you want to query for? Process executions or process injections by process name or the hash, and many more attributes. Do you want to search for file activities, file creates, writes, deletes, reads by file name or full path and file name, hash, many other attributes? Do you want to search for network connections, outgoing, incoming? Yeah. So for me, I'd like to search my logs, the logs we already have in Cortex XDR, coming from all of my pro agents, yeah, and other log sources that we can take logs from. We can then build a query. So I'm not sending a query out to all of my endpoints. Yeah, I'm just calling my query 6718, just so I can track it in the query center. And I'm going to ask XDR to look at the logs for all file activities for a file name of virus5.exe, virus5.asterisk, yeah, just in case. Previous name, you could add the full path if you want to, previous path, optionally MD5 or SHA-256 hash to match on exactly for this name. I could be generic. Yeah, I'm just looking based on this file name. I can add many attributes. And this is a file query. Yeah. The action disk driver name, the file system type. So there are many attributes we can select. I can even further filter it based on an active process. So only if Notepad touched this file or WScript accessed it, what was the active process that performed those file operations? Yeah. I'm not going to. And I can also further filter it based on a host or a series of hosts. That I'll do. So let's do a filter based on the host attributes. Hostname equals, hostname does not equal, hostname contains, hostname does not contain. Yeah, contains. All right, so contains, I'll just try 671. That should match enough of us. Yeah. Okay, hostname contains 671. Again, further attributes you can select, host OS or installation type. I'm not going to. Yeah. I'm not going to filter, refine it based on an active process. And what will be the time to look at in my logs? The last 24 hours worth of log activity, or the last 7 days, or the last month? And remember, by default, we only store the detailed logs for 1 month. We can't store every 5-minute EED uploads, yeah, forever. So that's why. So we'll do it over the last 24 hours. No, we'll do it over the last 7 days. Let's do that. Last 7 days. And it builds for us a query, yeah? So that's all the attributes we've now selected. And we have the choice of running it interactively or running it in the background. If you run in the background, we'll get a notification, yeah? It'll tell us when it's ready, give us a link to get to the action, the query center to go and look at it, or you can schedule it. Yeah, I'm just going to run it interactively. So here's the query it builds for us. This is not SQL. This is a query using the form-based query. And there we see now 380 results. Yeah, 380. File reads, file deletes, file writes from the 6713 and many other endpoints as well. 6712. Yeah. So we're looking at the log data in our Cortex data lake now. Yeah, we didn't send a request to those agents. It's important for me to point that out, right? If we need to rerun the query, maybe change the criteria, we have the ability to edit and then go and run it again. Yeah. Or schedule if you want to. And when you schedule a query, you're creating a schedule name. Yeah. It's a different name. It's a schedule name. And you're choosing whether to run it one time in the future on a specific date or to run it periodically. Run it every day. Yeah. Or every week, for example. So I won't do that either. And if I lost my query results, oh, I've lost them. I need to see those results again. We have our query center. This is where we manage our queries from. So here's the completed query from last time. I can right-click it, copy the query URL, give it to someone else, send it by Teams, rerun the query from here, schedule it, show results. I want to see the results again in a new tab. So that's not running the query again. That's just showing the results of when the query ran. Yeah. Virus5.exe, virus5.vbs. Yeah. It was good that I used just asterisks. All right. So I'll catch up on some slides anyway. Yeah, a lead can turn into an alert after we define it. That doesn't create alerts for us. We'll continue with that discussion afterwards. But you can see now that we've discovered, yeah, lots of that file activity in our environment, right? So lead investigation is threat hunting. It's what some of you have been doing for a long time. As an analyst, you can use our Cortex XDR investigation tools to find unknown hidden threats already in our data sets. Yeah, the proof that there have been connections to these IP addresses or this file activity, yeah, or this type of process interactions. So with Cortex XDR, the investigation flow for threat hunting is, first of all, we search for a lead using the query builder like I demonstrated. And that way we can determine suspicious attack intended events in our data sets. Yeah. We don't know if those files have been executed on 6712, on 671. We saw the file creates and delete, writes and things like that. So maybe we need to do further investigation. We need to further inspect events using causality and timeline analysis to determine impacted resources. Is there any persistence, file or registry changes, and other attributes, details that we need to know about? And we have the ability to configure Cortex XDR to alert us if it identifies that type of log activity. So that's what the creation of IOCs and BIOCs are. Yeah, we'll cover that in the next module. But if you want XDR to automatically alert based on those types of threat indicators, we tell it what to alert us on. I want you to alert us when we see virus5.asterisk, any type of file activity in our logs, yeah? The logs we already have or new logs that come in from our agents. Send us an alert straight away, yeah? All right, so we have the query center, which is where you manage all of your queries, see the results, the query builder I showed you as well, and schedule queries, all under further investigation options. All right, a query builder page helps you search for unknown threats already in your XDR data sets. Why do we need to do this? The management console, it shows us the alerts, it shows us incidents, but we don't provide you with a dedicated table for logs. Yeah, there's no way you can directly look at all the logs that have been coming from the different log sources, except, again, the management audit logs and the agent audit logs. So by learning how to utilize those queries using SQL and the query builder, it provides you with a way to view the logs already in your data sets. I want to search through firewall traffic log events that have been logged into our XDR, into our Cortex data lake. Query for Okta authentication log events. So there are two types of queries. There's the simple form-based query I showed you. So where you get to select the attributes, what type of query you'd like to perform. And there's the more advanced approach using the XDR query language. Why is it more powerful? Because you can search for any log attribute, not just the ones provided on the form. If it's not there on the form with a query builder, you can't search on it. And also with SQL, you can even correlate logs between two different data sets, multiple data sets. And we'll talk a bit about the data set management this afternoon, but when our agents send their alerts and logs, they log it to a data set name in our Cortex data lake that is different from the data set name that Azure AD would log to, or Okta would log to, or a syslog collector coming from our broker VM would send logs to for its third-party firewalls. So we have different data set names in the Cortex data lake. And with SQL, you can choose which data sets and correlate logs between them. All right, so here's our query builder, when you use the query builder, it gives you the two options. Do you want to straight away go towards SQL? This is this afternoon. Or would you like to use our form-based queries? Yeah, process, file, network. It tells you here, no one complained. The network form, the network queries, which sounds great. Search for network outgoing, incoming connections by IP address, by port. Yeah, I want to do that. But it's deprecated in the next release. They've had this for a long time in XDR. This is a new query, which provides even more options. You can still use network, or you can use network connections. So don't worry, it says this. We have the upgrade already. Yeah. Do you want to search for authentication events? Do you want to search for registry activity, image loads, DLL loads, process events, event log data coming from Windows and Linux event logs? So it's quite powerful. Yeah, even without learning SQL, for most of your query needs, you'll find the query builder is going to satisfy most of them. Yeah. All right, so I showed you a file query. Yeah, I did show you a file query. So yeah, when you generate a query with a builder, it will give you a default query name, but you can edit it as you saw. If it is going to be a file query, by default, it'll be all file activities. So here we've modified it to file creates or writes for this file name, note asterisk.txt. And if you wanted to further refine it, but based on a given SHA-256 or MD5 hash or a full path, you could. Yeah, that's further attributes for the file. We then have the actor process, which will be the acting process. So here we're going to use process name equals notepad.exe. We're going to do a query for creates and delete, creates and writes only if notepad.exe creates or writes this file name, note asterisk.txt. Yeah, if I use Notepad++, we won't get a result. We're looking specifically for notepad.exe as the actor process on this file name. Yeah. Further refine it based on host or hosts. You don't have to. You saw me do it for if the host name contains. Yeah. So with our pull down here, equals, not equals, contains, the squiggly and the equals, yeah, or the not contains. Your time frame. Yeah. Here's an example of the process queries. Are you looking for process execution or process injection? When you do a registry query, registry activities can be queried all by default, or creating a key, deleting a key, renaming a key, deleting the value, setting the registry value, and your network queries as well. So once you populate the query, and you then, choosing whether you would like to run it, what are your different options? The option I showed you can run in the foreground, wait until the query completes, run in the background, you get your notification on the left-hand side, and then expand it, shows you, go and view your query results from the query center. There's the schedule option, and you are creating a new scheduled query. Yeah, this is not the same query, it's a new it's a different object. We'll talk about that in a second. And there are two types of scheduled queries again. Do you want to run the query one time on a specific date? So one time in the future, it's non-periodic, to run once only at a future time, or there's periodic search query, run every day, run every week, for example. Or cancel. You can do cancel too if you like. All right, so here's our results. That's a result. Okay, let's find a results. Here's my results. In the results set, we have options of right-clicking on the results. Yeah. And further filtering, but I can now investigate causality chain. Open card in new tab. So that's the result, one of the results of the query, and I can do further causality analysis from there. There we go. Okay. We should be showing some forensics highlights. WScript was initiated from a remote terminal session with this IP address. In fact, we can even see that in the causality graph, an IP address node. We can't do anything on it. It's grayed out, unlike these ones where we can interact. But that's an IP address node. Yeah. All right. Actions again. That's for 6713. Okay, and some nice remediation suggestions. Yeah, it modified this VBS file. You go on manually remediate and changed registry keys as well. All right. So here where we're looking at the results of a query. This is a network outgoing connection. And then the option to investigate the causality chain. Questions? You don't have to. I can tell you a quiet group again. I'm trying not to go fast because there's not much content today, right? You're about to do a lab in a few slides. So managing queries, once you've built your query, if you lost it, you didn't look at the results, you go back to your query center. So we'll do that too. There it is. I didn't lose it. So from the query center, these are queries that were generated using XQL, and these are queries that were generated using the forms, a file form, file query, or process queries. So you can see the difference, yeah? Straight away, file, that indicates it was using the query builder. All the ones with XQL is XQL. So if I wanted to see the results of someone's query, yeah, I could scroll across. Whoa, wow. Yeah, there were 32 results for this query. Someone did a very big XQL query. It was probably me. And there were 37,000 results. Yeah, another big one over here, and there were 67,000. Yeah, so if I go and right click now and show results, yeah, there's going to be 67,000 results. I don't want to put too much. If you want to, you can, right? Here, for example, yeah, show the results. 8 results, 15 results. And again, you can see the results anytime you want to. And then do further analysis from the results by using the causality analysis graph. Oh, this is quite a nice one. So let's look at the query file. Action type is all. And the file name is funny.asterisk. And the host name contains 8501. And the event timestamp was last 24 hours before this date. And then we're seeing the query results, yeah? Kind of like I showed you before. So Query Center is where you get to look at the query results for any query that has run. And you can also manage them from here, rerun the same query if you want to. Schedule. So if you want to schedule a query, it gives you a new schedule name and asks you how you'd like to configure the schedule. So when we look in our query center, there are a series of columns, yeah? Query status, the query name, the description, number of results, and others, yeah? So just to point out what we're seeing when you look through the query center page, it's where you take actions, can see the results of a query, or the other right-click options. But what we see in that table view is a query name. So that's the friendly name you assign to the query. Yeah, when you do XQL, absolutely. Yeah, with XQL you can. Yeah, you just put a limit. You just define a limit in the query, and we'll learn how to do that for sure. Yeah, I was not brave enough to open up a query results with that many tens of thousands of results. But yeah, if you want 10, you just say limit 10 in the SQL itself. That's easy to do. Kent will see that this afternoon. Yeah. All right, so not with a form-based query though, right? So query name, friendly name that you assigned. This icon represents this as a scheduled query as well. Now, we don't see all columns by default, but you can, of course, include them. There is also an execution ID. The execution ID is a unique identifier generated when the query is run. Let's talk about this one first, though. This is probably better. When you create a query, we create a query ID number, an ID number for that query. Yeah. Every time you run the same query, it's the same query ID number you're running, but we give you a unique execution ID. I can run this one again. There'll be another execution ID. Yeah, it's still the same query, name and query ID number. We show you a column. The query status is a queued, running, failed, completed. You saw the num of results column. Was it 32,000 or 10,000? And also, if you go into the scheduled queries, there are no scheduled queries by default. You'll see the schedule time and the next execution. So the schedule time is the frequency or time at which the query is configured to run, and the next execution is when will it run next. Yeah. So none if it's a non-periodic query. And again, you can do a show of the executed queries as well. All right, so we're going to build up on that a little bit more because we're now seeing how to query the log data already available to our XDR. Yeah, so we can search for threats already hidden in our environment, but maybe I'd like XDR to generate for us alerts based on those hidden threats or threats that are discovered from the log data now coming in. So that's the next thing. But now we'd like you and, hopefully be able to investigate a lead using tools in XDR. You can now build a query using our query builder, manage them from the query center, and you understand the difference between our periodic and non-periodic scheduled queries. Non-periodic is once in the future. Periodic is a cycle, every day or every week. So if you have any more questions, you're welcome. Otherwise, I'll give you time for the lab. It doesn't matter what lab you're up to. I'm hoping that you did get up to end of, well, to be ready for this one, yeah? But we're exactly where we need to be. I'll say, please do this lab. We'll take a short morning tea break, and then we will return and start looking at how to build IOCs and BIOCs so that XDR will alert us based on those threats we'd like it to alert us on. All right, I will. Yeah, that's the right one. That's good. So activity 5.1, building and managing search queries. Call out anytime if you need help. Otherwise, I'll go quiet for you. Okay. Mhm. All right, looks like people that are doing lab have come towards the end of the lab. So let's take a short morning tea break. Yeah, good time for that. We'll come back in 20 minutes. We'll start the next module. IOCs, BIOCs. Yeah, very interesting. Other rule types. So I'll put the timer up and see you in 20. Okay, everyone, let's continue. Just about there. Very interesting module on using Cortex XDR rules. How we can configure our own rules in XDR so it will build us alerts. So we're going to understand what is an IOC, how to build one, what's a behavioral IOC. We'll talk about the global ones we have built in and how to create your own custom BIOCs, and also custom prevention rules, a very powerful feature to extend protection to the agent. We'll then go through IOC, BIOC suppression rules and correlation rules. I'll throw in one more. I'll throw in the new rule that we have. We have automation rule as well in XDR now. Okay, so not a huge module and a great lab. I really want you all to do the lab for it. So by the end of this one, you'll be able to differentiate and describe the difference between what is an IOC and a BIOC, the different types of indicators. You'll know how to create and manage them. You'll know how to provide extra power to your agent by configuring custom prevention rules. You'll know how to configure suppression rules to suppress some of those alerts and correlation rules. So the first one we go through is IOCs, indicators of compromise. Okay. So the idea of Cortex XDR rules, and we've already seen a couple of alerts being generated by XDR, but based on the rules within Cortex XDR, we have the ability to classify our own custom characteristics of threat indicators. And that way, if XDR matches activity in the existing data sets it has, or new logs that it receives, so live or historical data, where it's able to then generate alerts. So notice here we have two alerts down the bottom. I'll just find my pointer. And these are not alerts generated by the XDR agent. They're generated by Cortex XDR, an IOC alert and a BIOC alert. So the idea is it's Cortex XDR that's creating the alerts for us. They will become part of the relevant incident as well. And we'll learn how to combine BIOCs with your restrictions profiles so we can transfer some BIOC rules to your agent, to your XDR agent. So I'll talk more about that at the right time. Yeah. Okay. So why would we want to do this? Yeah. With an indicator of compromise, what's the difference between IOCs and BIOCs? An IOC is a static indicator of compromise, a known file name, a known file hash, a known IP address that you'd like to ask XDR to alert us on if it sees logs of that type of activity. So static, intended to detect known simple malware or known static indicators, known IP addresses you'd like to be alerted on when endpoints connect, for example. Whereas the behavioral indicators of compromise specify much more dynamic attack attributes. So much more complex behaviors, combinations of different activities, process operations, network connections, registry activity, combinations of different behaviors. And with the BIOC rules provided by Palo Alto Networks, many of them can even detect fileless attacks. A lot of modern malware these days may not be 100% fileless, but a lot of the malware these days, there might be a small dropper, and then a lot of the content is delivered not coming in a file over a network or by data already stored in another database in the registry even. So we can identify even fileless types of attacks if XDR identifies activity that matches those rules. And then we have correlation rules as well. With correlation rules, you have to use XQL. There's no other option. And with correlation, you can correlate the events from multiple data sets, from multiple log sources, and then generate a result. So we're going to go through all of them. So one by one, the first rule type we go through is IOCs, indicators of compromise. Again, intended to detect known simple malware. When you have a brand new Cortex XDR, we have no IOCs. Yeah. So I'm already here in detection rules, IOCs. there are 0 in a new Cortex instance. So we're using this in the lab a lot. Yeah. So if you ever wanted to add an IOC, it's a very simple process. Will it be a single IOC, or do you want to upload a file? What's the indicator name, the IP address, or the file name, or the file hash you'd like to XDR to alert us on? I won't use that. I'll use something else. Well, as you saw, if I select an IP address, yeah, it's identified that by type IP. Sometimes it doesn't auto detect it. So if I type in, you know, not that we're going to try to match on something like that, but wscript.exe, it didn't auto detect it. So sometimes be careful. So simple indicator name, yeah, you define the type. Is it an IP? Is it a full path and file name, or just the file name? Or is it a domain name? Yeah, so domain name www dot, you know, whatever, toyota.com as an example. Yeah, so that would be a domain. And what will be the severity of this indicator? Low, severe, informational. For me, it's not really a problem if someone wants to visit Toyota, right? So you have to choose the severity from critical through to informational. Remember that XDR can create informational. The agent only does low to critical. So that for me is informational. Add a comment. What's the reputation of this indicator? If it was a bad indicator, a bad IP address, a bad file name, what's the reputation of this indicator? Is it a good indicator, or is it a bad indicator, or suspicious? You know, no. No reputation for me. Yeah, it's not really a bad. I'm just using that as an example. Yeah, let's say bad site, bad company. That's better. Yeah. All right. So what's the reputation? Bad or suspicious. If there's going to be log activity of our agents trying to connect to this name. Yeah. And how reliable is this indicator? In a scale from completely reliable to reliability can't be judged. I'm going to say fairly reliable, somewhere in between. And then you choose, I'll have to minimize here a bit. When will be the expiration of this rule? When will this IOC expire? Will we use the default rule expiration for a domain, or are we going to define your own specific expiration date? Or there's no expiration for this indicator. You have to delete it or disable it yourself. So I'll say specific, and we'll choose, yeah, a specific date. There you go, 30th of December. Before yeah. The other option we have there when you add an indicator, if I edit it, yeah, you can say, I want to use the default, yeah? So the default, and I can't configure the default from here anymore. So I'll add it again. But if you want to configure the default rule expirations, yeah, we have defaults for different types of indicators. So if we use the default, yeah, for IP, we can say never in terms of when it will expire, or from 7 days to 180 days. For a domain name, when will we, if you choose default, what's the default rule expiration? For a hash, for a file path, for a file name. So again, we have 0 by default. It's up to you to add your own indicators. And then based on the log activity coming from your pro agents, you know, if XDR identifies that type of indicator, it will generate for us an alert. One thing we do in our lab is we upload a file. Yes, you can browse or drag and drop for a file. But the thing to consider with a file, I'll show you our file that we're going to use. You have a file on your client. Yeah. So the file that we're going to use, when you did the prep script, yeah, to prepare your Windows server, it prepared also this sample file, and it also includes your 4-digit code. Yeah. So this is an IP address. That's a full path. That's a file name. That's a domain name. And they all have our 4-digit code somewhere inside the MD5 hash or the SHA-256. You get the idea. So this is a file I could upload, but the only consideration, and I will in a second, the only consideration is they all of those indicators the file I have is in mixed format, not all IP addresses or all full path. Yeah, so mixed format's good, but they all need to share the same severity. The ones I dragged from the same file. So I'll take them. I'm going to drag and drop. Yeah. So I'm going to say, all right, all of those indicators in my file share the same severity. They're all medium severity. Yeah. The data format's identified as mixed. They all have to have the same reputation. Yeah. They all have to have the same reliability. They all are going to share the same expiration. So that's the only difference, or consideration, right? If you are going to use the upload file option, if you wanted to have different IPs with different severities as different indicators, yeah, use it in different files. Add them separately is what I'm trying to say. But I'll upload that, yeah? And that will upload all those indicators. All right, so I'll catch up on some slides. So quite simple for IOCs, yeah? Detection rules, IOCs. You can also import a list of IOCs from other threat intelligence sources. So when you look at the IOC table, we're looking at a table view of all the indicators, and we see the indicator name. And what we're talking about over here is when we look at the IOC rule list, we're seeing the indicator name, yeah, the type of indicator, IP, hash, domain name, the severity of the alert we would like XDR to generate, the number of alerts that have matched based on the indicator. Good one, Gordon. Yeah, Gordon's gone ahead already. Good on you. And yeah, expiration date as well. Comment if you assigned one, and the status, because of course we can disable if you want to an indicator. All right. All right, so that's what we're looking at here. Yeah, the indicator name in the indicator column. So that would be the file name or the IP address or the hash itself in the indicator column. And then you see the type. Again, full path, file name. So full path is the full path with the file name, yeah? Domain or hash. Expiration dates, never or a particular expiration, and the reputation as assigned when we created the indicator or edited it last. All right, so here's an example of defining a single indicator. You can enter the indicator name, choose the type, choose the severity, optionally a comment, a reputation from no reputation to suspicious, a reliability, and the expiration. The other option is the second tab across to upload a file. If all of my indicators have the same severity, reputation, reliability, and expiration, it doesn't need to be in mixed format. They could be all IPs or all full paths. Yeah. But here we're dragging and dropping a file in mixed file format. The data format is mixed. Right, to control the default rule expiration, different defaults for the different types of indicators. So have we seen any alerts so far? If we go back to our incident page, have we seen any IOC and BIOC alerts coming through from Cortex XDR? Well, let's have a look at this one incident. Yeah. And into our alerts and insights tab. Well, there's an XDR BIOC. We're going to talk about that next. Maybe we'll find some XDR IOCs as well, yeah? So many different alert sources that are not just the XDR agent. Can we do a filter based on just show me the XDR options? I want to see IOCs and BIOC alerts, and analytics BIOCs we'll end up talking about here as well, because I'll throw that into mostly BIOC so far. IOCs. And if they're not in here, here we go. Yeah. Okay. There was an indicator name that was matched. That's the IOC file name. And when it happened, and the endpoint details, analysis if required. Yeah. So an alert generated by Cortex XDR to give us information about the threat indicator you wanted alerting on. And we might also find them under insights as well. There you go. So BIOCs and some analytics BIOCs. So the analytics engine has its own rules, BIOC rules. We'll touch on that as well. All right, so there are IOCs to start off with. Based on the indicator configuration, if we added an indicator name of www.bagcompany.com, like I did, or ycar.org, the type is a domain, severity is high, and then XDR identifies log activity from one of our pro agents. A prevent agent doesn't log its activity, remember, yeah? So if we see log activity from one of our agents that matches on that domain, XDR generates for us a high severity alert. The category comes from the type of indicator, XDR IOC. Notice the icon for it's different as well. And the alert name is always IOC, but then in brackets, we have the specific indicator name. Yeah. So it could have been a file name, could have been the domain name, the hash, but we always see IOC, and then in brackets, the indicator name. Question. When we're using IOC BIC currently, we find that it can only detection in alerts. Can you block it? Yes. Okay, so yeah, that's why I'm trying to reinforce. It's very important to understand that with our indicators, our IOCs and BIOCs, let's go back here, with all the IOC and BIOC alerts, these are alerts that are generated by Cortex XDR, yeah? The agent knows nothing. You wanted to get additional information if the agent logged that type of activity, yeah? So that's why we added a custom BIOC or a custom IOC, or Palo Alto Network matched BIOC possibly. No, that's not Palo Alto, that's a custom one. Yeah, but Palo Alto Networks provide a whole bunch of custom, of built-in BIOCs, yeah? So yeah, we're gonna learn, Kent, how to extend that functionality to actually block that behavior on the agent, not just post-detection alerting in XDR, but to enforce the behavioral rule on the agent. So the agent, if it identifies that behavior itself, it blocks it, sends a prevention, gives a prevention alert pop-up to the user, sends the alert to XDR, yeah? So yes, Kent, we're gonna get there very soon. All right. So next up is BIOCs. Before I take you through the slides while we're here, in the same area, which I've already lost. So back on our detection rules, even though we have 0 IOCs and a new tenant, yeah, there are many BIOCs. As soon as you activate your new instance, your instance will perform dynamic content updates from Palo Alto Networks. So there are many BIOC rules that are not built in, but we receive them through dynamic content updates. Yeah, here I'm checking, causing the XDR to do a check. Yeah, here's the last version check. When we just did it now, we're on the right content release. So a lot of the ones we see here are from students. So first of all, let's filter the ones from Palo Alto Networks, not from students. So I'm just trying to find the source and find Palo Alto Networks to add that as a filter. Yeah. So I'm looking at enabled BIOCs where the source is Palo Alto Networks, and we found 373 out of 733. So there must be many that are disabled from Palo Alto Networks. They've disabled them through their content updates. Yeah. So my purpose here is not to try and go through every single BIOC rule, but let's look at the differences in the types of things we can match on. So here we have a BIOC rule created by Palo. Here's the rule name, suspicious executable created in the .NET directory. The type, a category, yeah, evasion or collection or persistence, credential access. And then we're looking at combinations of behaviors. It'll be file activity with this file path and an action type of create and process activity initiated by cmd.exe. And that's a very simple BIOC. Yeah. There are many more complex ones. Lateral movement, file path equals admin dollar, and the C drive and file name is exe, and the file path is not equal to, and the action type is this. So the idea is when XDR identifies log activity matching these behaviors, these are behaviors that Palo Alto have said, this should not happen. These are combinations of processes followed by other process activity that shouldn't happen. Yeah, or that you want to know about. Yeah. Registry activity, and if we hover over it, yeah, registry activity, and the host OS is Windows, yeah, it would be for a registry activity. Yeah, so we have many built-in BIOC rules, or again, provided through dynamic content updates to your tenant. Curl connects to an external network, exfiltration. So action type and network, action outgoing failed, and remote IP address is not a private IP address. And the remote port is not 53. And the process is initiated by curl. And the CGO signer is not Palo Alto Networks. Yeah. So these are behaviors that XDR will alert us based on. Yeah, again, I'm not trying to go through all of them. What we're seeing is combinations of different activities, yeah? What were our IOCs? Static file names, static hashes, a static indicator. This is combinations of different behaviors, file activities and process activities and registry activity. Yeah. And you can add your own as well. Did I click on the right thing? Yeah, I did. Yeah. We've seen this page before, haven't we? We've seen this option before. So let me remind you where we see that option before. When we try to do a query with a query builder, looks exactly the same, right? If I try to create a query with XDR, I have the option of using SQL to build a query or using our form-based query. And the same thing applies with BIOCs. If I try to add a BIOC, a custom BIOC rule, yeah, I can import from one tenant, export from one. Here, I really want to take all of these ones from my tenant, my custom rules, export them to another customer, export selected, and then import into the other customer. You can do that kind of thing too, right? Not trying to do that right now. So let's add a custom BIOC. And again, it gives you the same option. Would you like to add that custom behavioral indicator using SQL? So we can match on this process activity followed by this file activity, followed by this registry activity, and then this network connection. Or do you want to do it quite simple using our form-based approach? Yeah. I'll go process. So a BIOC rule, am I looking for process execution or process injection? So process is going to be notepad.exe. Yeah, something you'll do in the lab, for example. Notepad.exe, and make sure I spell it right, and I won't bother with a path or a hash for it. But when I use Notepad for a test, I'd like to be alerted if, for example, the file name includes a given string like my number or secret or something like that. Yeah, if it equals or contains, yeah, that value. And you can add more as well, yeah? If it contains another value, secrets, yeah? So Notepad with a command, basically a file name matching on one of these, yeah? Not equal to, not contains, no, contains, I want to say there, yeah. Oh, well, you do both? That's interesting. I've never noticed that before. I'm getting rid of that one. Okay. Contains 6718. And you can also match, for example, on a username. So only if we match on someone that does a run as administrator, you know? Yeah, that kind of thing. So whatever attributes you want. And this, you could further refine it based on process. Yeah, hosts. This is not the complete capability of the BIOC as well. You can add many more conditions to it. And they do normally recommend you would test it as well, because this isn't the end of the configuration of the rule. Sometimes if you don't refine your rule, you might end up with too many alerts, too many false positives. So they do recommend you do a test. It actually generates a query based on that, sees if there are any matches. So far, no. No process activity, execution, yeah, where the process name is notepad and the command contains 6718 and the target username is administrator. Yeah, so far, nothing. But anyway, I'm then going to say, all right, fine. I'm going to save my BIOC, confirm the name is correct. And then what type of behavior is it? Is it infiltration, lateral movement, maybe privilege escalation? It's a run as administrator. What's the severity? And you can optionally add up to 3 different MITRE tactics. Yeah, execution, privilege escalation, credential access, as you like, and optionally up to 3 different techniques. Do you want any exceptions? We'll cover that in a sec shortly, and then a comment for it as well if you want. And this will actually add the BIOC rule so that if there's any, again, log activity that matches that rule criteria, it's XDR that generates the alert. Yeah. Yeah. And you could edit and refine if you wanted to and further make it more complex if you need to. Yeah. What some people do as well, a very useful thing, if I go back to the BIOC list and we look at the BIOCs from Palo Alto Networks. So some customers do this. For the BIOCs from Palo Alto Networks, can I edit them? I can't. Can I delete them? I can't, but I can disable them. Yeah. Whereas a custom one, I can disable, delete, and edit. Yeah. The ones from Palo Alto Networks, you can't delete, but you can disable. You can't edit them. What if I wanted to edit one from Palo Alto Networks to make it more refined for my needs? Yeah. Yeah. So for example, this one here, I could always use the option save as new. I'll take another one. Take this one here, save as new. Yeah. And then give it my own modification, give it my own name. Yeah. Make whatever changes you needed to it and then save it off. So all I'm trying to show you is you can't edit the ones from Palo Alto Networks, but if you clone theirs, you can do whatever you like to it. It's a new custom rule. Hopefully that will be helpful for you. See, and it doesn't just have to be one type of activity, yeah? In my BIOC, it was purely process activities. Yeah, file and process and host and others. Registry, network. Any questions? You can, as I go through these slides, now that you've seen it, what is a BIOC rule? A BIOC is a behavioral indicator of compromise. And unlike the IOCs, we have global BIOCs provided by Palo Alto Networks. We get new ones dynamically through content updates to your XDR, yeah? To verify your content version, hover. To do a check for the content update, you do a click here, but it comes automatically. I showed you also you can export BIOC rules from one, so you can import into another instance. That can be very useful if you're going to be supporting multiple customers and creating custom BIOCs. You might model them in one tenant and then export from that tenant, import with appropriate changes to others. All right, so you've seen that part. There are 2 steps in configuring a BIOC rule. You saw with step 1, we get the same form, that we used when we created a query with a query builder. Step one, though, is this time we're adding a BIOC, either using SQL or using form-based queries. That's when it gives you the test or save option down the bottom. But even if you save, it's not finished yet, because you still have to go to step two, where you confirm your rule name. You then choose the type of behavior and the alert severity, again, up to 3 tactics and techniques, and a comment. So there's step one. Would you like to build the BIOC using SQL or using one of our forms? I wonder if that will work for me, by the way. Yeah. So if I do a run as administrator, that should actually work, right? I hope it will work. I think you'll do the same kind of thing in your lab. But who am I to start off with? We're logged on as student, right? So if I do a run as command and I run as user administrator, yeah, and I run my notepad and I match on my number with hello or whatever else I put in there, yeah, .txt. What's the password for administrator? Good question, Palo Alto. And then, okay, great. Yeah, I'll create that file. Hello. And save it off. And will that generate alert? Not yet. Yeah. Why won't we see alert yet in Cortex XDR? Because I haven't done my every 5-minute EED upload, most likely. Yeah. So I'm not going to force anything. I'm going to wait for the every 5-minute EED upload to occur. Yeah. And then we might very well see there is a new alert created by Cortex XDR that matches my BIOC rule. Yeah. We were matching on process activity for Notepad with username administrator, matching on that string in the command for Notepad. That's the idea. Yeah. All right. All right. So I took you through how to build the form-based BIOC. So we'll find that alert soon. Again, after you've configured step one or performed step one, you then have a choice of doing a test or straight away do a save. Yeah. And Palo Alto Networks' recommendation is do a test first. That's the best practice. Because if you have an unrefined BIOC rule, can't call me now. Yeah, it can really lead to lots of new noisy alerts, lots of alerts being placed into your incidents, too many false positives. Yeah. So best practice, do a test first. I wasn't expecting to have any matches when I did my test. I hadn't tried that type of activity. Yeah, but I made sure there weren't 10,000 results already. And then we do a save to go on to step two. And in step two, you already defined the name, but you can, yeah, confirm it or change it from here. We choose the type of behavior to define the category of the alert, the severity, of course, for the alert as well. And the alert name ends up as the alert name. Sorry, the BIOC rule name is your alert name, I should say. All right, so what do we see when we look at the BIOC table? Some columns are not included in the default view. You can include if you like, but there is a global rule ID. It is a globally unique ID number for a BIOC. That way, if you export from one tenant to another, it's still a unique rule ID. We then have the name, the BIOC rule name, which should have some description of the rule. A type, we saw dropper, evasion, and others. The behavior is the actual behavior that the rule is trying to match on, or combinations of behaviors. The severity of the alert that we want XDR to generate, the number of alerts it's already generated, and the source. A summary of the attack tactics and techniques you've defined. So if I go back here to our BIOC rule list now, and refresh. Oh, I was wondering what. All right, there's my privilege escalation category. No exceptions, no alerts yet. No alerts yet. Interesting. Someone's got theirs working well. 6521, well done. Yeah, good one. But I was hoping I could actually show you that and show you then the alerts. But anyway, here there are actually 2 alerts, yeah? Yeah, edit or open the rule builder. So yeah, we're looking at the columns we have in the BIOC rule table. If you right click on a rule, you can again disable and delete. If it's a custom rule you can delete, you can't delete the Palo Alto Networks rules. You can disable theirs. You can't edit theirs as I showed you. Export or clone. So if you do want to make changes to the ones provided by Palo Alto Networks, clone it with save as new, and then give it your own, custom name, make your changes to it. I cheated with my target username. Did I misspell it? Administrator? No, I did. See, if you mistype the username, mine's good. Target process command did contain 6718. I'm surprised I don't have any alerts yet, because my agent would have done its 5-minute EED upload by now. Come on. I'll click out of there and click back into it. Maybe we'll find it is now found 1, generated 1. No, still not. No, it's exceptions. Ah. Well, there's my one from last week. Yeah. Didn't do nothing different. Sure, what have I done? What is administrator? No, I did 6718. That's what we're matching on. Try one more time. I'm surprised. Yeah, there's my file. Hello again. I'll even save that as something different that still has the same string in it. Maybe find 2 BIOCs in that case after the EED upload. Yeah. So that's what, again, the agent is not doing any protection. Yeah. But if the agent logs that activity, those behaviors, I'm really expecting XDR to generate for us those alerts, and I can see that it hasn't yet. That's all. That's what I'm not happy about. 6718. No one can spot the problem, right? Execution of target process name notepad.exe, spelled correctly. Command contains 6718. Yes, that's true. And target username equals. Oh, that's why. Maybe that's why. Troubleshoot this together. Target process name contains administrator. Maybe I'll make it a bit more generic. Correct. Notepad.exe. Let's try one more time. Yeah. Save it off. Confirm it. All good. Update the comments. Updated comments before I could okay. So yeah, and by the way, with the BIOC rules, I won't need to do any activity on the endpoint again, because we're looking at historical and live data that comes into Cortex XDR. So if that refining of my rule works, yeah, because I said the name contains, yeah, administrator, instead of exactly matching just administrator, Why did I do that, by the way? Because my name is that, yeah? My name is 6718-win.1 / so it contains administrator, but is not equal to administrator, right? So XDR will match those rules against both historical and live data coming in. I can do it. I won't. You get the idea. We'll do hello 3 for a new one too. Okay, last time. Do an EDR upload, we'll see that new alert and historical alerts too. All right. Questions about BIOC rules? All right, now Kent asked the question before, IOCs and BIOCs, they are post-detection alerts. It's Cortex XDR that is creating for us the alert if it can match activity from log data it has or that comes in from the agents. Yeah. So a BIOC rule is detection only. The agent is unaware of the server-based BIOC rules that we have. So what we're now going to learn is a very advanced capability for Cortex XDR agents called custom prevention rules. With custom prevention rules, we can choose to take some BIOC rules in Cortex XDR and then transfer them to the agent by attaching them to the restrictions profile that they use. So we're now transferring BIOC rules to the agent, and that way it enables the agent to block activities that match the BIOC rules we transfer to them. Yeah. So the idea is what your agent will do is, and I'll show you how we configure the restrictions profile to enable this to happen. But what we're doing is we're transferring, remember the global behavioral threat protection module on the agent, one of our malware protection modules. We're using those BIOC rules as BTP rules for the behavioral threat protection module. So as we keep on monitoring all the activities on the agent, if the agent matches that activity based on your rule, it performs the prevention, terminates the process, send the alert. Yeah. I'm guessing that's from Kent. Yeah, so yeah, okay, good. So let's watch how simple this is. Very simple process. One more refresh, by the way, just out of interest. G3 quite slow today. Yay, 2 alerts finally. All right, so 2 alerts from my BIOC, one based on historical old and one based on new log data that came in. So we'll go to my alerts table. Yeah. Okay, so here is an alert. My alert name came from my rule name, matched one of my featured fields as well. And we see, yeah, the description is actually what the behavior that was matched on, initiated by run as, yeah. This is an alert, yeah, generated by Cortex XDR, a BIOC. And the actions are detected. So what if I want to prevent my agent, if we match this activity, to actually prevent it from allowing this activity, terminate the process? Yeah, so we'll go back to our BIOC rules. And this is what you do in the next lab. Yeah, we'll take whichever BIOC rules you want and transfer them to the agent, but it's a kind of a 2-step process. So the first thing I'm going to do, I'm going to go back to my endpoint policy management area and find my restrictions profile. Because first of all, we have to enable the setting on the restrictions profile to allow me to provide the rule to the agent. So I'm going to find just my profile starting with 6718. I'm going to open up my restrictions profile, hiding down the bottom there. And then in here, there is a section we've been through this before, yeah? How we enforce additional restrictions not enabled by default. I'd like to block executables from running from the temp directory, from the downloads directory, yeah? Things like that. Do I want to block executables from running from removable media drive files, from optical drive files? And we're in, yeah, block mode for those by default. Yeah, that's good. But down the bottom, our custom prevention rules, user-defined prevention rules with BIOCs is disabled. Yeah. So let's go and enable this feature. Yeah. So by enabling this, I can now choose to transfer the BIOC rule to this profile, to my restrictions profile. And there's a setting here to auto disable the rules that trigger more than 100 times in 30 minutes by default on all the agents that use this profile. And there are no custom prevention rules. I can't add them from here. I can see them from here and remove them from here, but I need to enable the feature on the profile. So quickly do that, save that. Find the BIOC rule I'd like to transfer to my agents. Yeah, this one here and whichever other ones I want. Yeah. It's being really weird. Okay, thank you. All right, so I'm taking two different BIOC rules. I'm going to right click on them and I'm using goodness, why would you let me do it? Interesting. It won't let me do multiple at once. All right. If I take the rule that I want to transfer to my agent, add to restrictions profile. Yeah, when I tried to add another one, it wouldn't let me. So which profile do you want to attach it to? This time we have a nice filter. They should provide this in the policy rules as well, a field, so you can see what you're typing, I think. Yeah. And I'm attaching it just to my restrictions profile. Okay, that's good. And then, of course, my agent's already using that policy with profile, but it has to get that policy update. So after the next check-in and the policy update, the agent would then use that as a BTP rule. And block the behavior. I know some of you aren't doing the lab, so I'm trying to demonstrate to make sure you see what's happening. So I'm going to make sure my agent does a check-in with a force check-in to get the policy and profile changes. I'll show you while that's happening. If we go back to my restrictions profile and we edit the restrictions profile again, and we jump down to custom prevention rules, we see the rule has been added to the restrictions profile. This is where we can remove it from here. Yeah, scroll across. There's already been 3 alerts. Good. So you can control it from here. Yeah, remove it if you want to, but you can't add them from here. So I'm hoping maybe if we do one more test, that behavior would be denied, prevented by the agent. Let's try one more time. There we go, right? So XDR block malicious activity, behavioral threat was detected. This was a rule used by my BTP module. All right, and there's the rule. We transferred that rule, which is used by the behavioral threat protection module now on the agent. Kent, that's exactly what you wanted. Yeah. And you can do this for the more complex rules too. Yeah. All right. So that's custom prevention rules. We're transferring BIOC rules. Very helpful. Thank you very much. I really appreciate the feedback as well. It helps me. So we can do this for Windows, Mac, and Linux. Yeah. Transfer the BIOC rule as a BTP rule. Behavioral threat protection. So it's 2 steps. Yeah. First of all, in the restrictions profile, we jump down to custom prevention rules. The use of user-defined prevention rules with BIOCs is disabled, so you must enable. Once you've done that, you then go to the BIOC that you want to transfer, and you can select multiple profiles. Maybe I want it for, again, the different restrictions profile for different sets of servers. Yeah. Or workstations, as the case may be. So you can choose multiple profiles to attach the rule to. Next time the agent does their check-in, they then get that rule update. All right. And almost the last part, IOC and BIOC suppression rules. We also do have suppression rules. There might be times when you want to configure when not to be matched. Yeah. So there might be certain exceptions. Even though I have these IOCs and BIOC rules, I want to create certain exceptions. So it's the same kind of capability for both. Yeah. Let me show you an example of it. Easy to get your head around. So where do we find this? We're going into our settings and then under exceptions configuration. Yeah. Here is where we have the IOC and BIOC suppression rules. Again, there might be exceptions to certain IOCs and BIOCs that you've added where you don't want to get those alerts. So you can create a rule. This will be, I don't know if I'll save it, but anyway, 6718 test IOC suppression rule. And then we go through the rule conditions. When do we want to suppress the alerts? Yeah. So this is exception criteria. All criteria must be matched for the exception to apply. If the BIOC rule is there, but we're matching on this hash, or we match on this file name, yeah, suppress the alert. We don't want to see the alert. It's to create an exception. Yeah. So if it's signed by Microsoft or it's signed by VMware or whatever it is, yeah, I can configure a rule suppression and then choose what the scope will be. Will it be scoped to all the IOC rules or just the BIOC rules? All of them. Or all the IOCs and all the BIOCs? Yeah. Or just specific BIOC rules? And then it gives you a summary and you save it off. So it's got a way of saying, even though I've got the rule, the IOC or BIOC, if we match this criteria, suppress the alert from being generated. Yeah, it's a suppression rule. Okay. So maybe useful to you. I hope it is at some stage. And again, the scope, you get to choose IOC, BIOC, all of them, or specific. All right, the last rule type from the module, but I'm going to add one more before I give you lab. Correlation rules. Now, with correlation rules, you must use SQL, so you'll feel more confident doing it this afternoon. But it's a special type of rule because you can correlate the events from multiple data sets using SQL. I could correlate the events from my Okta data set against the events from my XDR data set, or a data set where a third-party firewall is logging. Yeah. So we can correlate logs from two different data sets. And if we then match what you're trying to query based on, you must schedule it. The only way we can create a correlation rule is to schedule it daily or hourly. And what it does is it evaluates the query over your logs. And if we match, if there's a result based on your rule, there's only two possible actions. We'll either create alerts or we can save the result to a different data set. So look, let me give you a quick example of this. Under our detection rules, we're not going to build one because a correlation rule requires SQL. There are none by default, but if you do try to add one, you give it a rule name, you do have to build the SQL query itself. Yeah. Optionally alert suppression, but you choose your action. What do you want to do based on the match of that query? Do you want to generate an alert or do you want to save the result to a different data set? And you get to choose a data set name to create. In our Cortex Data Lake, You can export that data set later if you wanted to, or you just want to generate alerts. Yeah. So let me give you a use case. This is a use case that Palo Alto Networks provides, yeah, about correlation rules. Normally, if we provide you with a tool so you can identify the threat indicator in our environment using our built-in tools, build it as an IOC if you can. It's very simple, yeah? If it's not that kind of simple static indicator, and you can do it by configuring logic in a BIOC, well, then do it that way, because it's also going to be easier than configuring a correlation rule. But with a correlation rule, listen to this part now, an example Palo Alto Networks provide, you could create a correlation rule to correlate the events from your Okta data set, for example, to identify user activity, user logon activity for the same user logging on in the same, in a 24-hour period from 3 different countries. Yeah. And that might be normal for some of you guys. Yeah. Some of you might travel from Malaysia to Hong Kong to Singapore in one 24-hour period. Yeah. That might be maybe once in a while you do that, but still we might want an alert. And it's not something we can do with one of our IOCs or BIOCs, but it's something you could do with a correlation rule. Yeah. Because you're able to query any data set, 1 or 2 different data sets. So that's a good example, yeah? Let's look at authentication activity from Okta and the same user in 3 different countries in 24 hours. At least give us alerts. Yeah, we might need to do further investigation or, yeah, suspend that user ID. All right. That's my best example. So here's an example of correlation rules. Again, there are 0 by in a brand new Cortex XDR. The rule is always written in SQL. It's always a scheduled rule. It runs periodically, and there's only 2 possible actions: to create alert or to save the results to a different data set. Here is the new correlation rule process. Give it a rule name, build your SQL, choose the schedule for the rule. Whether you'd like to run the query against logs created in the last 1 hour, or last 6 hours, or 1 day, or whatever it is. And then what do you want as the action? To generate the alert? What will be the alert settings? Or do you want to save the result to a different target data set? Could be an existing data set, can be a new data set. And we'll cover data set management later. There is also an alert field mapping section. Sometimes the alerts that come in from an external log source, they don't map to the alert fields that we use within Cortex XDR. So we have an alert field mapping section, so you can map the data from your SQL query to specific alert fields. Try this option first, use pre-configured XDR alert field mappings. Otherwise, you can choose your own mapped fields and your unmapped fields, the fields that you'd like to use and extract. Very rare you'll need that, but that's correlation rule support. Module summary. Hopefully now you have a better understanding of IOCs and BIOCs. More static indicators, more behavioral, complex indicators, how to create and manage them, how to transfer BIOC rules to your agent as custom prevention rules by enabling the setting on the restrictions profile and then attaching it to the restrictions profile. Correlation rules, one more. The module's finished, but before you do your lab, there is a new feature in Cortex XDR that you will like as well. It relates to this module. So before you do the lab, just one more quick bit. And where do they hide this? They hid it under our incident management. Incident response. Okay. So under our incident response, we also have for response automation. And this is pretty cool. We have 0 automation rules by default. And you can add your own automation rule to ask Cortex XDR to automate based on your rule conditions, different types of actions. So let's just do a quick test. This is going to be my test auto rule. Okay, and my rule will be enabled. And what will be my automation criteria? It'll be based on alert criteria. If the endpoint host name is equal to that, yeah, and the severity equals high, I'm going to just add a few things in there into my rule criteria. And it's not an XDR BIOC, yeah. So hide rows with XDR BIOC, so it makes that a not equal to, yeah. I'm just using this as an example and could add whatever other conditions I want, yeah. Well, what do you want the action to be? Yeah, I'm going to change this from my agent, severity equals high or critical. Yeah, it'll make more sense. And the alert source is not XDR BIOC. It's come from the agent, for example. Well, then what do you want us to automate? That's step 2. Yeah, we've already found 20 matching results, but what do you want us to automate? And here are our different automation actions. We have communication options, send an email automatically, send a Slack message, or syslog. Or we have alert and incident management, assign to an incident, set the alert severity level, set the alert status under investigation. Or we have endpoint response, automatic endpoint isolation. We can automate retrieving of a file, running an endpoint script, initiating a malware scan, or terminate the causality. Yeah. I'm not going to do this. Do you want to exclude certain endpoints? Yeah, not based on my rule criteria, but you keep on going. Do you want to exclude certain endpoints? Yeah. No, I don't. And then skip. And there's the summary. So hope that's useful for you too. I think that's new from 3.6. Yeah. And that's good because this is a 3.6 class. We're running version 3.8 now, but it is a 3.6 class. Yeah. What am I doing, Jerry? Yeah. Any questions, anyone? Okay, so you have time now to perform activity 6.1, 6.2, and 6.3. It will be too early for lunch, most likely, by the time you finish. So when I see that you are coming towards the end or I hear done, thank you for those sending dones in the chat. We will do another short presentation before lunch. We still have a 1 o'clock lunch break. We're planning for 1 p.m. lunch. So lab time now. Let me know when you're done. I'll be quiet for you. Enjoy. Okay, everyone, looks like people are coming towards the end of the lab. Let's start the next module in 10 minutes. Give us a good session before lunch. Okay, we're getting there. We're now going to look at a short module on Cortex XDR assets. Yeah, so very interesting module to understand how we discover and inventory and manage your network assets. We see a couple of different views we haven't seen before. Yeah, so asset inventory, network configuration, and we'll talk a bit about the vulnerability assessment that we can perform if you have the Host Insights add-on, which we do. So we'll have a look at that too. All right, so by the end of this module, you'll be able to describe Cortex XDR network asset types, managed versus unmanaged, how to investigate an IP address using the IP view. So one of the advanced investigative views we haven't seen before, how to define an IP address range and domains, so you can choose what to scan when you want to scan, and so we can assign the subnet where our assets are. How we perform network discovery, we have a number of different methods. So what are the different ways that XDR can discover your network assets? And how do we identify the vulnerabilities in your network? We can't patch them for you, but we will identify them for you. Okay, so the first part of this module is understanding the asset inventory to begin with. Cortex XDR has the ability to build up an asset inventory for us. We already have information about our managed assets, so we need to understand the difference between different asset types. What is a network asset? It's anything with an IP address. Yeah, could be a printer, could be a router, could be one of our agents. And so we have the difference between a managed asset that has a Cortex XDR agent installed, and an unmanaged asset is an IP address that doesn't have our agent. Anything else, switch, whatever, IP phone. So why does it matter for us to discover your unmanaged network assets? We already provide a lot of detail about your managed assets. Your unmanaged assets are most often and very commonly vulnerable and open to attacks. So they could be IoT devices in the environment, or not necessarily. There might be unprotected endpoints. So it's important that we know that they're there, so you can then track them down and identify what needs to be done to secure them to the best of their capabilities. So we present you with an asset inventory. Yeah. So under asset inventory, we have all your assets. You can go under specific assets to look at just your on-prem assets or cloud compute instances. So from the all asset list, we've already found 93 assets in this example. We've already done some cloud integration with this tenant. We perform cloud integration with AWS. So what we're seeing in the asset list are some instances running in AWS. One has a name of Kali, the other one's OK Ubuntu. Their IP address or IP addresses, the type of asset, on-prem or cloud compute instance. These don't have our XDR agents installed. You can certainly run our agents on cloud compute instances, but we've discovered them through cloud integration by taking in the logs from AWS. So we've identified the cloud provider and the region in which the instance is running. Here's one of our on-prem assets, has the XDR agent, one of our workstations or servers. And there can be multiple sources how we learned about the asset. Yeah. So yes is a managed asset and no is an unmanaged asset. Yeah, maybe we need to make sure we've secured these instances in AWS appropriately. So under assets, yeah, one of the areas we haven't been before, we've progressively got through from EDU 260, yeah, how to add favorites, you know about dashboards and reports now. We've been extensively through incident response, not just the incidents and investigation options, but we've even been through response and incident configuration where we do our starring rules and featured fields. We went through detection rules today, and now we're going through assets. And we, of course, been through endpoints quite a bit as well. So under the, first of all, network configuration, there are many built-in IP address ranges, range names created by Palo Alto Networks. Yeah, I just tried to delete a lot from the students, but it wouldn't let me multiple select them and delete them, unfortunately. But anyway, yeah, you can add your own IP address ranges. That way, if we find a host or an agent or an asset in that IP address range, we will label this as its range name, just for documentation purposes. Subnet 1, subnet 2, data center, 1, whatever it is. So network configuration is also used when you want to scan. We're going to learn how to configure the broker VM to perform scanning of whichever ranges we want using ICMP or TCP scans. Yeah. So that's part of our asset area, the network configuration. We'll go through vulnerability assessment at the right time. We have our asset inventory, all of your assets listed, or can break down by on-prem versus cloud compute. We haven't got any cloud compute instances in this lab. Yeah, so nothing to show you there. So they're all on-prem assets. Also, the other thing we can ingest through your asset inventory is the cloud inventory. So if we're taking in your cloud provider logs, we are providing an inventory through Cortex XDR of your compute instances. And when one's deleted, when's one's created, where is it running? Storage buckets, VPCs, security groups, cloud functions, network interfaces. So this is done through cloud integration that we can provide the cloud inventory as well. AWS, GCP, Azure, I'm sure you could find others that are supported too. But going back to our asset inventory, some of these assets are, well, all the ones we see here, they all have XDR agents. Yeah. One Windows 10. The rest of Windows 2012 R2 servers. Their MAC addresses are different, even though their IPs are the same. Yeah, their MAC addresses are different. And when was the asset first observed? When was the asset last observed? And what source did we use to learn about the asset? How did we learn about the asset in the sources column? So for a managed asset, it is learned by itself. It's the XDR agent. But here we can see one of the assets was learned through Windows Event Collector by looking at a Windows event log. Another asset was learned by using the Broker VM scanner and two other methods, Windows Event Collector and XDR agent. So again, we can have multiple sources of learning about the same asset. Which asset was that, by the way? Okay, 192.168.1.10. Yeah, I don't know what that is. Oh, it's our default gateway. Yes, we do. It's our default gateway. That's our router. That's our virtual router that gets us to the internet. This is our domain controller that we log on against when you log on as pan/student on the server. All right. Internal IP address ranges. So what IP address range is this asset on? So this asset is on all of these ranges. Yeah, it's because when we do the lab for this, we often have many ranges that match on the same IP address, yeah? So all of these ranges include this IP address. That's why I was trying to delete them before I started this module. Yeah. Okay. So there's the asset inventory. What do we see in the columns in the asset table? The sources that were used to learn about the asset, to discover it. The internal IP range or ranges. We keep on scrolling. First observed when the asset was first seen in our logs. Last observed when it was last seen. So maybe we haven't seen the asset for 6 months. Yeah, first seen 6 months ago, or last seen 6 months ago. Yeah. And another thing we can do from within the asset inventory is when you select an asset, now please take note, I'm selecting mine, but I might have a weird result because we all have the same IP address. But what we're about to look at is there is an option within the asset inventory when you right click to open the IP view of the selected asset. And for many of you, you haven't seen this advanced view before. So this is one of the Cortex XDR advanced investigative views called the IP view. I didn't want to show it to you if you sat the 260 class with me, because I want to save some really good things towards the end of the last day. Yeah. So this is the IP view. And what we're showing you for that asset, notice again, it's found the wrong IP. It's actually found the wrong server. We all have the same IP address in this lab. But anyway, what it does show is it identifies how many network operations on that IP in the last 7 days, and then recent open incidents. And if you want to see the others, you can view more too. And what we show you in the main graphical portion, we're showing you your network connections, outgoing connections from this IP. And primarily, we're showing it to you by destination country, US. I think that's France, or I don't know what it was, France or Russia, I'm not sure. Yeah, private IP addresses. So primarily by destination country by default, but we can change. And secondary by app ID. Actually, I'm not seeing any applications. I'm not, there we go. Click on the country, and then I can see the applications. Yeah. By app ID, not by ports. And then the node size, the circle size, is based on the number of connections, not the total download or the total upload or the total traffic. It's based on number of sessions or connections. And we're only showing top 3. We can show you the bottom 3 or the top 5 or bottom 5. And you can choose the time frame of 24 hours or 7 days. Yeah. So let's do that. Let's change to the top 5 in the last 7 days. We have to apply when you change the cluster data by options, and then apply searches through the logs we have in the Cortex data lake. Yeah, because my pro agents are logging their network connections, remember. Yeah, so give it some time to render it. I don't know why it's taking so long. Doesn't usually. Let's go back to top 3 and apply that again. And all we really have in this lab, these aren't servers. I mean, they are servers in terms of the operating system, but we're not providing inbound access to those servers. Okay. Reach the max 100,000 number of results. Okay. Couldn't display it. So let me try something else. Let's try outgoing network connections, this time by destination IP address and secondary by destination port. Node size, number of connections or total traffic, that's fine. Show just the top 3 in the last 24 hours. That's probably what it didn't like, my time frame. Let's try that. Outgoing network connections from this IP address. So to this destination IP address, multicast, and the port number. To this destination address, and the port number is NetBIOS. Yeah. On the local network, we're doing a broadcast to our domain controller, 192.168.1.25. We're then seeing secondary by port, 53, 139, 389 LDAP, and others. So this is a special capability of Cortex XDR because we have Pro enabled. And our Pro agent, every 5 minutes, sends EED, including its network connection details. If this was a server on my DMZ, in my private cloud, for example, yeah, maybe I want to look at the incoming connections. For us, we're not going to see anything, yeah? We don't have any, we'll have a look. Incoming by source IP, yeah, try. What will we see? But yeah, it's not like we're providing access to the outside from the outside world. We are seeing some incomings. It's interesting through the router. Yeah. And the other thing we can show you, if you have the Host Insights add-on, is show me host insights about this IP address from the IP address view, primarily by users or applications or auto runs or drivers, because of the Host Insights add-on we have that's enabled for our Pro agents. Yeah. And then apply that to, okay, lab user logged in, guest logged in, admin logged in, normal accounts. Yeah. So through Host Insights. Don't know if it's, is it doing anything for me? Okay, it's found a fixed drive. It's found a fixed CD-ROM. Great. So I know you like that. I know you're happy with that, right? If you haven't seen that, you can click on the asset, get asset details. Yeah. Like you do when you click on alert, but you're getting asset endpoint administration. It's a pro agent connected, endpoint details, agent details, network details, and the policy details, and options for live terminal asset view. And the asset view is different from the IP view, yeah? So the IP view that we just looked at, okay, in this case, the same kind of thing, but we've gone back to the IP view for it. There's an actions button here as well, live terminal. All right, so I showed you how to work a bit with network assets. One of the options we have from the asset inventory is to open the IP view, or do you want to do an open and quick launcher, do a query for this IP address? You click on one of the assets, we have the side panel options and the side panel actions. All right, within the IP view itself, we're by default looking at network connections, outgoing. Remember, you can change your options, incoming, or use the insights. Yeah, it also does show another side panel. For me, it was on the left, but details about that asset, network connections we saw in the last 7 days, and the incident area as well, and can click on them to get to those incidents. Change your cluster by view options. We're looking at primary by destination country again, and secondary by app ID. We click on the flag, we see those applications we've identified. Anytime you make changes, remember to click apply. There's the apply on the top right there. So they're your different data clustering options. I won't read them through, taking you through them already. Yeah. And we saw also we had one difference, not just network connections, but because of the Host Insights add-on, we had the option to look at Host Insights. Yeah, with many different options. It's a VMware VM with physical memory of 6 gig. I didn't realize. There you go. Yeah, I had no idea. No, I did. Okay. Again, there's the apply button on the right next to the time frame. So do apply. And then we show you the illustration, in this case, of those outgoing connections from the IP address, primarily by destination IP, and then secondary by port, by destination port, if that's what you selected. And this is a top 5 display as well. So that can be invaluable for further investigation. You need to work out what connections has our server made outbound to the internet. Yeah. Where's it receiving connections from? And again, only a capability because we're sending that log every 5 minutes from Pro. So one of the takeaways from this class for all of you, for you and your customers, is we have more capabilities in terms of advanced analysis and response when we have the Pro license. And it costs more, but you get more. You get what you pay for, right? The volumes of each protocol. All right. So that's a bit about the asset inventory. Now, one of the methods we have for discovering network assets is to scan using the network mapper, an applet on the broker VM. I'll show you that too. But one of the things you'll do, besides, there are many different ways we have for automated node discovery. Yeah, we saw, for example, your Cortex XDR agents are identified straight away, but we can also identify assets from the XDR agents logs, from Windows event logs, from looking at the ARP cache, IP addresses they've resolved to MAC addresses. So they're on the local network. the broker VM, what we're about to look at, the network mapper, one of the benefits of integrating the XDR with your Windows DHCP servers with DHCP collector is we can see all of the served assets that aren't running our agent. We have Pathfinder, a special data collector, and we can even take in EDR data collected from firewall logs. So there are many different methods to discover assets. If you do want to use the broker VM's network mapper, we have to tell it which IP address range or ranges to scan. So in the IP address ranges, again, we have many predefined ranges from Palo Alto Networks to include multicast, loopbacks, private IP address ranges, things like that. But it's up to you to add your own ranges. And even if you don't want to use the network mapper applet on broker VM, we still show you in your asset inventory the name of the address range that the asset is attached to. Yeah, so still a good idea to configure your IP address ranges. I'm not going to, because I can never succeed. I always conflict with someone else's IP address range. That's why I tried to delete them before I started this. So one of the issues is it won't let us configure overlapping ranges, exactly the same ranges. And in our lab, lots of students have already configured, not exactly matching. Yeah. Yeah, this way it works. But if we can't have two exactly the same first address and last address, it won't let you. Yeah. So I'll try to do my way. I'll try to call mine to 6718 range. And I'm going to scan from 192. And you can see you have different options there. Do you want to do a first IP address dash a last IP address? Or do you want to do a range or just one IP address without a dash? Or do you want to do the CIDR like a network and a mask? I can say 192 dot whatever 168.0.0/16. Yeah, you can do a whole block if you wanted to. Whatever you like. But I'm not going to do that. So I'll do 192, 168. I'll try .1.0. And it won't let you until it's correct syntax. .1. Let's scan anything. 218. I hope that doesn't conflict. Okay, well, I got it there. All right. So I created my own IP address range. Fantastic. And if you have a problem when you do the lab, you'll just need to, try and find an end last IP address that doesn't conflict. I used my last two numbers at 200 plus my last two numbers. Yeah, maybe not a bad idea. Anyway, while I'm here, if I do want to configure my broker VM to perform the scanning of that IP address ranges, what I just created, we have to go back to our broker VM that we registered on Wednesday for some people. If you did not do the lab on Wednesday, the last day of 260 this week, when we do this lab, they'll ask you to go through the steps to connect to your broker VM and to register it. Yeah, to our Cortex XDR instance. My broker VM has already been registered. So I'm just trying to be patient, trying to stall. And I'm going to find, I don't need to go to its web UI from my VM. I can control it directly from here, of course, yeah. Thank you for your patience. Sorry, it's taking some. There we go. Finally. Okay. So my broker VM, I did register it on Wednesday and I renamed it to include my name. So the device name should contain Jerry. And my broker VM is disconnected. That's not a good thing. That's not a good thing. Because we need to connect to it. So I can configure it. So how am I going to troubleshoot that? If you have the same problem, I'm going to try to connect to my broker VM from the web page. It's really not responding. It's really not there. Oh. Oh, it is there. Strange. So it's responding by ping, but it won't respond by HTTPS. So maybe this lab is not going to work exactly. If you have the same problem with your broker VM, I don't know if we'll fix this in time. The lab team are very good to assist us with problems, but I don't know how fast they'll be in fixing this issue for me, for my pod. So I hope your broker VM is good. Yeah, because mine looks like, yeah, I can ping it, but it doesn't reply by SSL anymore. Yeah. All right, so I won't try and demonstrate that. What I was going to try and show you from the broker VM, I could go through the option to add an applet. But first, I've got to configure my applet, Network Mapper, and then it gives you two options. Do you want to use ICMP Echo or TCP SYN to scan the address ranges you're going to define down here? With TCP SYN, you choose which ports to scan, up to 1,000 ports, so 1 to 1,000 would work. Yeah. Some people ask me, can I use both? Well, you could, but you need two different broker VMs, or you need to change the network mapper configuration yourself, because we are scheduling the network mapper to run with this configuration daily or weekly or monthly. So you could go and change it if you need to, yeah, and choose which of our IP address ranges you'd like to scan. We're here adding multiple. So that's what I was hoping to demonstrate, but I can't. I don't have my broker VM. What I can demonstrate, we'll leave this for after lunch. Leave a good part for after lunch. So let's have a short lunch break. Not short, let's have a decent lunch break. Let's come back at 1:45, finish off the last few slides and give you time for this lab. Yeah. If you have a shorter lunch break and you need to catch up on labs, you do that too. Otherwise, we will resume at 1:45 to finish just the last part on vulnerability assessment. Yeah. Okay, see you soon. That's fair for lunch on the last day, on a Friday.